Hey guys, welcome back to the stream. We're here with our 11th and close to the last class for Showdown JavaScript. We've been going through JavaScript to learn it and contribute to various open source repositories with a focus on Showdown because that's where most of you guys are going to be coming from. So it'll allow you a chance to take a look at what's going on here, how JavaScript works, that kind of stuff. If you're here for the first time, we're pretty far in, so there is a document with all the information in it, including links to prior episodes. If not, welcome back. We're just gonna hop right into it, I suppose. Fairly quiet day today, but that's fine. So today's episode specifically is on classes, and like I said in my notification, it's not a class as in teaching you how to teach. That's not at all what that means. Classes are not sure how to describe it. They're something you can use in JavaScript. A simple way to describe it would be that they're like an object factory. You can create objects with them. They're very versatile. They're used to mass produce objects, and you could do a lot with them, really. So one example from Showdown is you have a lot of users on Showdown. So like, let's see, right now there are 14,084 users on Showdown. So each user has its own, needs to have information on it. So you have to have information on the user's connection so the server can communicate with it and identify who's who, their username, their ELO for various formats that they're playing in, so we know how to handle that stuff, and all sorts of other information on that user, whether they're punished, whatever it happens to be. That's all in what we call a user object, which is an object that's designed to hold user information. Now, I'm not going to go into detail about how all it works and such, but what I do want to go into with it is that each user object is created from a user class. So the class defines what a user object looks like, what properties it has, what fields it has, and what methods it has. And that way I could say, oh, this is a user object, I can do this to it every time. Now, of course, there are differences in the data, like one user's name could be Home Hero, like that would be mine, and yours could be whatever your username on Showdown is, or whatever you choose it to be if you don't have one. There's various differences like that, and that's perfectly fine. That's all part of programming, and it's a good thing. So we're gonna go into an example here, shall we? Let's go ahead and just hop straight into that. So, new day, blank page. Classes are, like I said, object factories. So they're defined with the class keyword. You start with class, then you need to name your class. A naming convention for a class, unlike a variable where you would use like let word, you'd use camel case, which is like this. The first word is lowercase letter, starts with lowercase, and the rest of them start with uppercase letters. In this case, with classes, you just uppercase from the beginning, so not camel case as an example. That's the naming convention, at least. And as for a name, let's see, what should I sample here? Well, we were talking about user objects, so let's make something simple. Let's just call it class user. Set of curly braces completes the basic outline of class. And if you're wondering, I do take questions in chat if you're interested in asking any. So feel free to drop them in and I'll be happy to try to clarify anything. Alright, so class user. So we've created a extremely basic and completely useless class here. The concept here is we're just going to model a user on Showdown, just some basic information. We're not going to dive into details like connections and whatever. So there's a couple things classes can have. They can have properties and they can have values. So like with any object, so like let's say we had a user object called user, or I'm going to call it user object to make it clear. No confusion there, preferably. Hey Plant Bee, how's it going? User objects can have properties, and you can define any you want. You can add more later and technically remove them. So if you wanted to have like name, test, whatever, you can do that. 5 or something, you know, whatever you want. Same thing applies to classes. You can add these values and you can create them anywhere, though generally it's wisest to initialize these when you create the class. I'm glad to hear you're doing good. So the first thing we're going to go over is initializing a class. So obviously you could just use what you have here, nothing, not bother initializing. And that's sometimes okay if you don't need to initialize anything and you just need to want to make use of some methods involved in the class. But most of the time you're going to want to. So when you create, because you have to create, like they said, it's an object factory, you have to tell it to create an object. We'll get to that soon. But when you do that, it calls a special method called the constructor, which you can have one of per class. It's usually at the very top of the class's declaration, and you declare it by typing constructor. It's a method, so you set it up like any other method. Set of curly braces, done. Now you set it up like this. You don't need to do constructor function. No, you just do it like this. This is method shorthand. It's valid for methods too, and it's what you use in classes. So if you wanted to create a method called method, you could do this inside of a class. I'm pretty sure it's also valid in objects as of, yes it is valid in objects as of the more recent Node versions. So if you're confused about that, hopefully that helps. So again, the constructor can take arguments, which I'll teach you how to pass later. In this case, let's pass a name argument. It's a user, let's give them a name. Okay, so we're going to initialize some things. So we can't initialize methods inside the constructor. That's done automatically outside of it. What we're doing is initializing the properties. So like if we were, let's change this. We'll just do like, yeah. So let's say we wanted to make it like this user object up here, this one we declared in the format we've seen before. So to create these instance variables, these properties, instance variable is a name you might see in other languages like Java and C#. You do this, which, like I said, this keyword is very useful in classes when I previously talked about in objects. This refers to whatever object was specifically created, or we're creating. So this refers to the object we're creating inside the constructor. So for example, let's say this.name. So this.name equal name. So we set the name property on the object we're creating to the argument name that was passed to the constructor. If that's too confusing, then I can possibly clarify it by changing the name of that argument to name prop, and then set that to name prop. It shows that they're different. This is not the same as this in the sense that they aren't the exact same argument. They're not the same thing. They have the same value now because we've assigned them to each other, obviously. Now I'm going to move that back to name. And we also had a guest num. I'm just going to set that to 1. You can declare it literally as well. Like if it was a proper thing, we'll make this proper. Let next guest num equal 1 equal next guest num. There, that would be more proper. So like each user on Showdown has a unique guest number, which is used as their name before they're logged into a name. in this case, we just set their guest number to the next guest number, and then we increment that by 1 for later. It's declared outside of it, so it's not affected. It'll be different each time. So, for the name, I'm actually going to move this around a bit. If we're going to be strict with our code, we want to do like if name or type of name does not equal string name equal guest plus this dot guest num. So simple enough, that would be like guest1, guest2, whatever, if it's not a valid name that was passed as an argument. It's a bit of validation. That's a very simple way to do it. We could potentially add more properties later, but I think that's enough for now. Any questions? That's a very simple overview of the constructor. We're just setting up properties in there, so any class we create, any object that we create from the user class will have a property called guestNum, which should be some kind of number, 1 or greater, based on the logic we put in there. And it should have a name property, which is a string, which by default would be guest, the word guest plus a space plus whatever their guest number is, or whatever was passed as an argument. Okay, I'll give you guys a little bit to answer because I'm not sure how far behind the stream is, and if I unmute, you'll get echoes. So, in the meantime, what is going on, Inspector? Okay, we're fine. Okay. I'll take that as you guys are okay. So, methods. Methods, aka functions inside of an object, for anyone confused about that, are defined pretty simply in a class. You just put them inside these braces here. So like constructor is a method that's called when the object is created from the class. It's the first thing that's run, and you're pretty sure you can call methods that are outside of it, because those are already initialized. So let's add a method called change name. Say you want to change your name later. So new name. It takes an argument called new name, the name you want to change to. So this is the basic way to set up a method inside of a class. It's method shorthand, and you can do this inside of an object too. So if we wanted to copy paste this up here, we can do that in a bit. We'll go ahead and do that after we write it inside the class. So change name, we'll just go ahead and do the same kind of check here, but just return stop the method if it's invalid. And I'll need to do new name, not that. And then if that's fine, then this.name equal new name. And let's say we also want to have a method to reset the name, like just change it back to guest. This actually exists on a Showdown user object. We could do this.change name. You can call methods inside of other methods just like this. Guest, this.guest num. That resets the name back to the default. So again, like I said, these are valid up here. Gotta add their commas though. That's one key difference. Inside of an object, you have to have a comma after each property or method. Inside of here, you do not have to have one after that. So what we have so far is a constructor, which is called when the class is created. It sets up various properties. A method called change name, which checks which takes one argument, new name. If new name is a falsy value like undefined, which is the main thing I'm looking for there, or it's not a string. Actually, this needs to be strict. I am thinking in the wrong language. It's not a string, then we do not do anything, we just stop. You might want to throw or something in other times, but we haven't gotten into that yet. We'll do errors soon. throwing them, catching them, playing ball with them, and things like that. If it's valid after that check, we set the name. Again, it has to be this to refer to the object you're working with. You cannot just do name equal. You could do that in other languages, but not JavaScript. You have to do this dot name equal new name. So this dot name refers to the object you're working with. So when you have 14,000 copies of this object, you need to make sure you're editing the right one. And to do that, the best way is this, because it refers to whichever one you're specifically working with, because you won't always have a reference to that object outside of, the object itself. Inside of it. Because otherwise you'd have to have like an object argument every time, and then you do object.name, and it's just, no. This is much simpler, honestly. And reset name, which shows that we can call methods of the same class inside of it. You can call methods inside of methods, of course. And this dot change name, and we just set it to guest plus guest num. So that's a few very simple things that you can do here. So now, like we said, it will come out to something like this up here. But we're going to actually set this to -1 because difference. Alright, so we're going to now show the difference between our user object and the one we create from a user class, which probably won't be much. So to create one, you can just do it without assigning to a variable, but there's really not much of a point without doing that in most cases. So we're going to assign it to a variable. So we're going to do let created user equal. So we're going to create a variable called created user, and we're going to assign it to something. We're going to assign it to a user object that we're creating from this user class. So to do that, first you need to invoke it with the new keyword. So new tells JavaScript, okay, we're creating something new. In this case, user. So new user. It means we're creating a new version of this user class. So when you do this, when you say new user, you're also calling the constructor method. So you have to include a pair of parentheses. So that's basically the same thing as saying new user, and it's calling the constructor. So this takes one argument name. We could leave this blank and it would just be guest1 in this case, because this is 1 at first and it'll increment after. We could also set something, so like Twitch or something would give it the name Twitch. But for now, let's leave it, let's leave it blank. So let's log our users. We're going to log user object, and we're going to log created user. Let's see if I can remember what my file path is. Alright. And there we go. Okay, so we're going to go ahead and run this. So node classes.js, the name of the file. So as we run that, we see the output is a little bit different. So first we logged our object that we created by hand. It has a name of test, a string. It has a guest num of -1, the number, and it's two methods, functions, change name and reset name. Meanwhile, our user object says it's a user in front of it, which is the class it was invoked from. And it has a guest num of 1 and a name of guest1. It doesn't show the methods though. The methods are there though. They're part of the user class. They just don't show when we're logging. These two are basically identical. The only difference is the name's properties value and the guest num value, which is fine. They're meant to be customizable. So let's do something with this. So if we wanted to modify created users values, we'd have to do like created user.name equal whatever, and we'd have to validate each time, and that can be messy. But if we want to modify our user, we can just go ahead and make some changes. So let's say created user dot change name. Let's change the name to Twitch and then log it. No, JS, that's not helpful. There, VS Code. So we're calling the change name method, and as you can see, the name is now Twitch. So again, it changes each time. And you can reset it afterwards. So if we wanted to like go in here and created user.reset name and then console.log created user, you will see that we are logging it twice. It's Twitch and now it's guest 1. Like I said, you can change these values, etc. Those methods do exist on it. Lots you can do there. Are there any questions so far from anyone? Okay. Take that as no. Alright, one moment. Alright, let's see here. Next up, we're going to dive into subclasses. So, well, I'm not going to get rid of all that text, but we are going to comment most about what is a subclass, and also, as a result, what is a superclass. Well, there's a bit of a difference here. Subclasses and superclasses. The idea is that you have these object factories. Well, no, I need to use a different term. It's called inheritance. It's a better term to use. So, inheritance is the concept that one thing inherits from another. So, if you've heard that with other things, like you may inherit genes from your parents, or inherit money from someone who dies, or whatever. You gain attributes of theirs, and that's the idea of it here with classes. A subclass inherits things from its superclass. So it's also called an is-a relationship versus a has-a relationship. But first, let me type out the idea of a subclass and a superclass. So we have our class user up here. Actually, no, I'm going to use a different thing. That's not a good thing, for example. So let's say we had a class animal. This is a concept used by a lot of programming books. And it can have whatever properties in it. Or if you wanted to be more specific, you could have like class dog or something. Animal. We'll just stick with animal. So you have your animal class, and that's pretty generic. It's able to represent any animal that exists, and okay, cool. There's things like it's alive and it breathes in some way, shape, and form, and other things like that. But there's a lot of different animals. You can't really just generalize to say all animals are warm-blooded. No. All animals have spots. No. All animals have fur. No, they don't. I'm sure you guys can figure that out. That's the idea of inheritance. While they all do share a few different things, they branch off and become more specific. A dog is different from a cat, different from a cow, a snake, a whatever. A koala. So you might have a dog class, and if you had like all these classes, like class dog, class cat, and in honor of Australia, who's going through hard times, class koala. They all have their different attributes, but they share a few different things. It'd be a bit of code duplication to just rewrite the same methods and such that they all share, wouldn't it? That's the idea of inheritance. The idea of inheritance is you would have your common values here, and then all three of these classes would inherit said common values. Inherited common values, and then you would have your specific ones. Dog specific values. If I copy paste this to here, and here and change this to cat specific values, and over here to koala specific values. Values, properties, methods, whatever. It works a lot better, honestly. You only have to write those common animal values once to handle whatever it happens to be. Now, obviously, we're not going to program actual animals, but you could do things like that. So, that's the idea of inheritance, and the big concept of inheritance is a versus has a. So, an is a relationship is where you could say something is something else. So like you could say a dog is a animal. I know it's is an animal, but grammar aside. Meanwhile, you cannot say like a boat is an animal. Now there's a difference between this and something else. Another relationship that you might see and be confused with is a has a relationship. And a has a relationship is more like with a car. A car has a steering wheel. A steering wheel is not a car is not a steering wheel, but they work together still. You'd expect to see a steering wheel in a car. It has a steering wheel. So, has a car has a steering wheel, among other things. They aren't necessarily part of the car, exactly the car itself, but they are a critical part of the car. And that's perfectly fine, just like you could say a cat has a pair of ears or something. Inheritance can be a bit messy, but if you keep it relatively simple, it can be helpful for you. A Showdown example would be the room game system. On Showdown, we have a generic room game class that has a bunch of useful methods that any game can make use of, such as creating, destroying, applying itself to rooms, sending messages to users, keeping track of players, things like that. And then a specific game would inherit those values and add its own custom values. So like Uno would add all its information on the cards and tracking all that, etc., and make use of the room game API to interface with Showdown. So for creating a subclass, let's do a superclass first. So the superclass is the class that is inherited from. And yes, a subclass can be a superclass. You can chain inheritance. You could have animal, dog inherits animal, and then you could have a specific breed like golden retriever inherits dog. That further is detailed. That would mean dog is a superclass to golden retriever, but a subclass to animal. Totally legal to do that. So, this case we're going to do our example. Class Pokemon. So, this describes a generic Pokemon, and we're not going to go into super detail here because there's a lot of data that goes into a Pokemon. But let's just give it, let's start with our constructor. Let's have a species value. That's species equals species. I don't really have a good way to validate this right now, so we're just going to take whatever they say. I guess we could do if type of, if I could type species does not equal string. Species equal, we're defaulting to Ludicolo because whatever. I don't know. I'm not even going to bother with validation here. It's whatever. It's just an example. But it's generally good to do so. Species. Let's give it a few other pieces of information, like normally you'd implement various calculation methods. I'm trying to think of some stuff because I do want to use this for an assignment, but not reveal all the info. Let's add types, sure. Types equal some array. We'll do type 1, type 2. We'll just, pass those in. We'll assume they're strings. We'll just stick with this, sure. Sure, something simple like this. We're just gonna skip over the rest of the details because, you know, again, complicated. And I don't want to dig into that right now. But we're just going to go with species and type for now on our generic Pokemon class. So let's create a specific Pokemon. So let's do, obviously, my favorite and the thing that's about the stream. So class Ludicolo. We don't declare it exactly like this. This is the general format, but first we have to tell it it's inheriting. So to do that, we use the keyword extends. This means that class Ludicolo is a subclass of Pokemon. In this case, because we said it's Pokemon. So Ludicolo extends Pokemon. Now this inherits the stuff from Pokemon. Almost. First, we have to set up our constructor as usual, and we could do details there. But to get this constructor to work properly, we have to pass details as appropriate. And to do that, we need to call our superclasses constructor. So to do that, we use the keyword super. Super is a special method. You don't need to do this.super, just super in this case. And it calls the constructor for your superclass. So in this case, it's calling this. So species is Ludicolo, type 1 is water, type 2 is grass. So some details have been filled out, and we can add our own details, like we could do, like let's say we have moves equals empty that. We could override values as well. We could do this, and you don't have to just only override. You can create your own custom values. So like this dot moves equals scald, giga drain, ice beam, focus blast. We could also just, instead of just this dot moves equal, we could do this dot moves dot push, add these 4 values, because this dot moves is defined. Again, we called super, so it's run the constructor. Ludicolo has all of these values in it. However, this was told to set it up, and since we passed these arguments, we know species is Ludicolo, types is an array containing water and grass strings, and moves is an empty array. So we can do this. Perfectly legal. We can also add our own custom values. So if we wanted to do something like, I don't know, this dot Pokedex entry, the carefree Pokemon, you could do something like that. And that would be Ludicolo specific, though I don't think we'd want that specifically, because I don't think we need anything that specific to Ludicolo. Let's add a method to Pokemon to give that example. So let's call it useMove. And we'll take one argument, index, and then let move equal this dot moves index if move doesn't exist. So we're gonna return console.log, and we're just gonna say, if I could type that would help, this dot species tried to use a move it doesn't know. Sure. Otherwise it does console.log this dot species used move. So the logic here is pretty simple. Index is intended to be a number between 0 and 3, or whatever the max. It's an index. We're attempting to index the array moves, so it should be a valid index. So we try to grab it, this dot moves index. So if it's empty, that's going to be undefined all the time, so default this will never work. But since we filled it up in our Ludicolo class, if we create a Ludicolo, 0, 1, 2, and 3 will work, because again, arrays are 0 indexed, meaning it will return a string, which means this check will not pass. But if the move doesn't exist, it will say species tried to use a move it doesn't know. Otherwise, it'll log species used move. Now, obviously, that's really oversimplified for a simulator, and I'm not asking anyone to code a battle simulator. We already have one of those. That's just an example of it. So, like, we'll show calling that in a second, but the Ludicolo class has this method. It can make use of it. And any other class that extends from Pokemon would have it too. So, imagine your favorite Pokemon. You set up its 4 moves, you create the subclass, and then you call use move on it. It'll just say used whatever move you selected. So if you have 4 different Pokemon and you tell them all to use the move in index 0, and it happens, one of them could say Ludicolo used Scald, another could say Arcanine used Flamethrower, a third might say Swampert used Earthquake, or whatever it happens to be. It's different for each one. Hey, Creative Cult, thank you for the follow. Welcome. How you doing? But that's the concept behind it. It's the concept behind extending classes. All these subclasses have these values of the superclass, which means you know they are all similar, just like with all the objects you would create from user. We know all user objects have a property change name, have a property reset name. You can do these on all user objects. I expect that to work. And for all classes that extend Pokemon, I expect them to be able to use a move. Mirbee's great. Make my emote? I don't actually recall asking, but I do appreciate artwork. Aloe. Ah, yeah. Okay. Well, I really appreciate that. I was kind of hoping Soul would show up, but I guess he's busy right now. That's fine, though. It's nice having someone to talk to, honestly. Today has been unusually quiet. Either way, we're gonna keep going before I get too off track. Let's see here. Let's see. You can add specific methods or whatever for the subclass as well, but of course do remember that if like I added something for Ludicolo specifically, like let's say dance or whatever, and console.log whoops, this.species danced or whatever, something silly like that. Only Ludicolo would be able to use that, not any Pokemon. So like if I create a Heatran class or something like that, class Heatran extends Pokemon, and I try to call dance and I didn't define dance in Heatran, and I definitely didn't do it in the Pokemon class, well that's going to error because that method doesn't exist. At least for Heatran it exists for Ludicolo. So do be careful in that area, but that's not a bad thing still. This is a perfectly valid thing to do. You know all Ludicolos will be able to dance, and they have various attributes that all Pokemon can do as well. It's not a bad thing at all. It's very powerful. So let's create another Pokemon as a sample. Would anyone like me to create a specific species? Anyone at all? I'd be happy to make a species on request for this example. Whatever you happen to like. Class. Let me think of something in case somebody doesn't. We'll just do Appleton for now. I think I want to do 3 anyways, so. Extends Pokemon. So we're going to do our constructor again. And this is going to take no arguments because we don't need any. At least I don't feel we need any for this example. You can add some, of course, if you want to. It's very flexible. Grass, dragon, this dot moves dot push. We're going to add, let's go with leech seed, apple acid, dragon, no, Draco meteor. And what was the 4th one that I use? Recycle. Speaking that, you could, you know, give Pokemon items or whatever too, and abilities and all that stuff. It's all up to you, of course. And for Appleton, we'll just what does Appleton do? I don't think there's anything generic you expect Appleton to do. So we'll just not. I guess we'll just do like sleep or something. This, that species slept. Whatever. There's an example. And this third one, let's see, did anyone request a species? No? Okay. We'll just do 2 then. So let's create some objects. Let Pokemon 1 equal new Ludicolo. That doesn't take any arguments. The subclass constructor takes no arguments. And let Pokemon 2 equal new Appleton. So Pokemon 1.use move. Let's use index O, and we'll also have Pokemon 2 use move O. So both of those have this property. So as you can see here in our classes, neither of them have use move defined. Again, it's all from the Pokemon class. So when that runs, we could do that. And Pokemon 1, since it's a Ludicolo, can use the dance method, but Pokemon 2 cannot because it's a different. Instead, it can use sleep. So if I run this code, so Ludicolo used Scald, Appleton used Leech Seed, Ludicolo danced, Appleton slept. Very simple little setup there. Again, the first line that was logged was from Pokemon 1, which is created from the Ludicolo class, and we passed the species as Ludicolo to Pokemon, so that's where that came from, and we pushed the first move in the move array, Scald, so that's where that came from. And same thing with Appleton, just different species name, different move, that kind of stuff. But all of it inherits from Pokemon, so we were able to use it on both of them. And you could even completely make something up if you made a fake mon. You could do class whatever that fake mon's name is, extends Pokemon, add the info, yada yada, done. That kind of stuff is done on side Showdown servers as well, to make fake mons, and people mess around with them. Now there's always frustrations with sprites because that's custom client required. Let's see. So that's extending classes and that kind of stuff. Is there any questions on that? Be happy to dive into questions. And if you're just joining us now, welcome, welcome. I'm happy to take any questions you may have about the class in general, me in general, whatever it happens to be. Otherwise, we'll just wait here a moment to give people a chance to ask questions. Then we'll move into a few other sections. Okay, cool. I'm not seeing anything on Discord or Twitch. If you're still typing, don't stop. Just drop it in and I'll get to it still. So, if you're coming from another language, if you're an experienced programmer in other languages, you may see some similarities here. And honestly, hold on. Sorry about that. I feel it's important to view the difference between these areas. Specifically, I feel it's important that we look at what some other languages can offer, because you can see these in TypeScript, and honestly, if you're going to go into other object-oriented languages, you're going to come into this. So we're going to peek into that a bit. I'm going to be using this C# file as an example. This very simple C# file. I'm not going to be teaching C# or the details, but just the concept of a class in another language like C# or Java. So like, you know, class program at this point. You create whatever. In other languages, you have various modifiers on instance variables and properties inside of classes. So in this case, you could see the name of this method is main, but there's public static void before it. So the first thing is public. The concept behind that is it's an access modifier. And this kind of thing exists in TypeScript too, and technically exists in JavaScript in the sense that everything is public. So access modifiers restrict access to different areas. It involves a topic called encapsulation, which I'm not going to dive deep into, but it basically means restricting access to code. And that's not a bad thing. Like restriction, you can only interface with this thing here, not elsewhere, so you can't mess things up. So there's three here, three that I'm going to talk about. Public is the one that is basically the one used in JavaScript, and the default in TypeScript, which is used in Showdown, and it's basically JavaScript but with additional capabilities such as these. Public means anything can use it, anything can see and use it, so a public method can be used by anything. So if I go and want to call useMove, if useMove is public, then I can use it from literally anywhere as long as I call the correct instance variable. The next one is protected, which indicates it can only be used from either within the class itself or within sub or superclasses. So you have to be part of that class change. Subclasses specifically, you can't really use it from a superclass. It doesn't make sense. The superclass doesn't really know its subclasses. So if the use case for this, for example, let's say useMove was protected, we wouldn't be able to do what we did here. We wouldn't be able to do Pokemon that useMove, but like if I called useMove inside a constructor, that would still be valid. Protected means it can be used by Pokemon or its subclass, Appleton or Ludicolo or whatever. So the Ludicolo class would be able to call useMove still while it's protected. The last modifier is private. Private is the strictest modifier. It indicates that this method or property or whatever can only be accessed, used, whatever, by the class itself. So for example, if you made the dance method private on Ludicolo, then only the Ludicolo class itself can use private. You cannot call this.dance outside of the Ludicolo class or anything like that. You can only call this.dance from inside of it. So in this case, you would have to call it from the constructor or make something else that calls it. Nowhere else. It's very strict. And that's not necessarily a bad thing for encapsulation. So these concepts are good to know. The second one you may see actually exists in JavaScript too, and I did not go over it. Shame on me. Static. Static we will go over in JavaScript first, so I will skip that for the moment, but it's an extra modifier that you can just skip sometimes. Lastly, void. In other languages, you have to specify the return type, because in these languages you don't just say var whatever equals something and change it to whatever you like. In these other languages, they're strictly typed like TypeScript, meaning if you declare something as a number, it must stay a number. So in this case, you have to define what the return type will be. Void meaning it doesn't return anything specific. It returns undefined in JavaScript. So I could do just plain return. That's fine. But if I do like return 5, that's an error. Obviously, it's not going to show up. VS Code doesn't have the stuff set up for error checking on C#, and I haven't tried to compile it or anything. But yeah, that's that concept. So static properties. You can have a static property on a class. So what is, or static method or whatever. So what is a static property anyways? So most things, if you want to access something from a class, like we did here, down here with the Pokemon classes, useMove, etc., you have to initialize it. Like we created Pokemon 1 equal new Ludicolo. We created a copy from the factory. So it's like we created a new Ludicolo from the Ludicolo factory, even though that sounds a little weird. And we could create as many as we want. We could create thousands, sure, and make them all a little different. Whatever you want to do. You can give one of them Fire Blast, even though that's not legal. A static property is a bit different. It's like you're accessing something on the factory itself. You don't need to create something. So let's add a static method to Pokemon. Now, a static method, because you don't need to create an instance from it, you cannot use anything that's not also static inside a Pokemon. So if we're creating something in this Pokemon that's static or whatever, then we can't call useMove from it because we're just doing something in the factory. We're not calling it on a created property or anything like that. So let's do static. Let's just say print message because I can't think of anything created right now. Console.log. This is an uncreative static method because, again, I can't think of anything good right now. So static print message. What does, let me correct my case. I'm going back to my C# roots. What does this mean? What does this do? Well, you could call Pokemon1.printMessage, sure, but you can also just call Pokemon.printMessage. That's the concept here. So Pokemon is the class name. Like I said, you cannot just call Pokemon.useMove. You have to initialize it. You have to make an instance of it. But with static methods and properties and all that, you can just do this. So if we run this code, the usual stuff from what we had before that I didn't comment out was run, and then this is an uncreative static method. That static method ran. So while most things in a class you will want to just be something you have to create an instance for, a copy of the whatever it is for, and no, the copies don't have to be identical. That's kind of the point of it. A static method might be something that you want to be the same for every class usable outside of the class. One example, we don't use static methods much, honestly. You generally don't, but one example from Showdown that I can think of is the Mafia plugin. So the Mafia game, again, it's a subclass of the Room Game API. So again, you can put these on sub and superclasses or anything. Has a static method called parseRole. So parseRole's job is to turn a string that represents a Mafia role into a role object. It's an intensive little process that took a lot of thought, and it's pretty complicated, honestly. We're trying to improve it. Anyways, it's static so that it can be used anywhere, both inside of the game and outside of a game. If you just want to, I'm pretty sure there's a command that allows you to just turn a roll string into a roll and to test what it would come out to. So it allows you to parse that information. So we can use that anywhere. We don't need to have a game running to use it, is the idea. Now when we do want to use it in a game, the downside is that we have to use mafiatracker.parseRole instead of just this.parseRole, but that's okay. That's really a fine trade-off for the situation. But that's the only thing we need to use that when the game isn't running. So all the other methods like day, night, whatever, if you've never played Mafia and you don't understand what the game is, that's fine. Are just, they only need to be used in the game, so they are not static. Alright. Any questions? Any at all? Okay, cool. That covers classes. So I'm going to try to keep this short so we don't drag this out much longer, but there is an assignment for today that I'm not quite done with yet, so I'm just going to describe the basic idea here. It will be linked in the description when I get to it. It will be linked in the chats and all that stuff. It'll all be linked everywhere when it is done and set up. I just need to double check my work, all that kind of stuff, you know. I don't want to give you guys a bad assignment. But the idea is you are going to be coding a simple Safari zone, or the concept of it. So the last assignment that I gave you where you were writing code and submitting it to me was an assignment called the route assignment, which we haven't gone over the solution for, so let's do that now. Oh, excuse me. Pokemon route simulation. This kind of concept applies to our new one. Your goal here was to simulate a player walking through tall grass, a cave, or surfing on water in a location in a Pokemon game. So if you've ever played a Pokemon game, which if you're watching this you probably have, but if you haven't, if you step in certain tiles, you have a chance to trigger an encounter with a wild Pokemon. This isn't including the newest games. This assignment was written before Sword and Shield came out, so we weren't 100% sure how it would work, but you would just randomly encounter these Pokemon in grass or whatever. Or on water, or when in a cave, even though there's really not many caves in Sword and Shield. Anyways, it's focused on objects, methods, and arrays. So the requirements were to have an object to contain information about the route/location that contains the name of it, a property called grass or cave or water that contains another object, or which should have Pokemon names as properties, the ones that can appear, and the values should be an array with the 0th index being the minimum level the Pokemon can appear at, and the first index being the max level it can appear at. All the encounters should have a range of at least 3 levels inclusive. In other words, 3 to 5, 18 to 20, 98 to 100, whatever. 3 total. So a method that should be run each time the simulated player takes a step. The method should take an argument which has the type of encounter the player would get if they find a Pokemon, grass, cave, or water. A percent of the time of your choosing an encounter should occur. If one is going to occur, call the method that handles running encounters. Another method that should be called when the method that is run when a player takes a step to determine and a Pokemon appears. Basically, this is the method that handles encounters. The method should take an argument which has the type of the encounter the player is about to experience, and should randomly determine which Pokemon appears and at what level. Simply log what Pokemon appeared and what level and the encounter type to the console. After logging the above, try to catch the Pokemon with a single Pokeball throw. Use a new method, see below. If the Pokeball throw method returns true, log that the Pokemon was caught. If not, log that it broke and fled. A third method called when a Pokeball is thrown. This method takes no arguments and returns true if it's caught and false if not. Simply return true a certain percentage of the time of your choosing. Pretty simple. In theory. It can get complicated when you get into the details. So the simulated player should take 500 steps through the route, each of which can spawn a Pokemon. Should keep track of how many Pokemon the player has encountered and how many they caught. At the start of the script, log that the player is entering the location, use the name property, and at the end log that the player left, and again use the name property, and then log how many Pokemon were encountered and how many were caught. So bonus steps were bonus 1 for 50 steps. Have the encounter type change from one type to another, e.g. steps 1 through 250 grass, steps 250 through 299 are water, and steps 300 through 500 are grass. The encounter types and levels should change as a result of this. And bonus 2, make it possible to encounter shiny Pokemon and record how many were encountered caught. The base shiny rate in Generation 7, the latest as of the time of the writing of this assignment, it was 1 out of 8,092. You can also use the reduced rate of 1 out of 4,096, or whatever rate you want. I really don't care. At the end of the script, also log how many shiny Pokemon were encountered and caught. And then a few useful tools I listed were math.round, which rounds a number down to the nearest integer, using the normal, or rounds up or down, whatever the normal rules are. Floor, which rounds down always, seal, which rounds up always, and random returns a random number, which includes a lot of decimal places, between 0 and 1, including 0 but not including 1. And finally, if you put \n in a string, it acts like a line break, allowing you to space out your content as you log to the console. The set of hints provided were: don't repeat yourself as usual, take your time and plan what you need to do and turn it into code, then write the code. After that, test, debug, and improve. The usual steps. You gotta plan out what you're going to do before you can write it. You need to make use of the tools above to calculate levels and other things, along with math. And arrays are 0 index, meaning that in hello, comma, world, hello is located at index 0 and world is at 1, and the usual ask questions. So I wrote my version of this. So we didn't have classes or anything at the time. I might have used a class if I could, but again. So const route, create an object that cannot be changed called route. It has a name property, route 102. It has two objects here, grass and water. Grass contains various properties in Pokemon that are encounterable: Poochyena, Zigzagoon, Wurmple, Lotad, Seedot, Ralts, and Surskit, and their levels, most of them ranging from 2 to 4, a few 3 to 5s. Water is pretty similar, but at higher levels. Marill, Azumarill, Surskit, and Masquerain, ranging anywhere from the lowest level being 15 to the highest level being 27, and it all depends on the species. So methods, try encounter. This is the method where it checks if you can encounter. Takes the type, which defaults to grass, and there's a 10% chance to encounter a Pokemon. So math.random times 100, so that's going to generate a decimal between 0 and 1, not including 1, but can include 0, and multiply that by 100, so that's going to turn it from anywhere from 0 to 1 to anywhere from 0 to 99 with a number of decimal places, and math.floor gets rid of those decimal places while rounding down, meaning it's going to be an integer between 0 and 99. If that whole value is less than or equal to 9, so 0 through 9, 10 different numbers, we return this .run encounter type, so we call the run encounter on the same object. Run encounter is the main method here. It handles most of the work. We have validation. If the type is not grass, cave, or water, or we don't have the type inside of it, we console log error invalid encounter type. So we have a number of, where did I keep those? Yeah, down here we have a number of tracking values. Encountered, the number of Pokemon we've encountered. Catch count, the number of Pokemon we caught. Shiny appeared, the shiny encounters, and shiny caught, the number of shiny Pokemon caught. So encountered plus, we have encountered a new Pokemon, increment that value. So first we get our encounter list. So object.keys gets a list of the property names for a object. So this type, so this refers to this object, and type is going to be grass, water, cave, something like this. In this case, grass or water, and it should exist because we did validate it already. Usually grass, so it's going, if it was grass, it would get the strings Poochyena, Zigzagoon, Wurmple, Lotad, Seedot, Ralts, Surskit. So then from there, we have this array of those now. Species is going to be equal to encounters math.floor math.random times encounters.length. So breaking that down, again, math.random, one of those decimal numbers between 0 and 1, not including 1, including 0, and you multiply that by the number of encounters possible. So that's going to give you a number anywhere between 0 and encounters.length. Encounters.length is always 1 greater than the last index. So if the last index is 7, it will be 8. So we use floor here to force it down. Now, the decimal generated will never be 1, so you will never have length times 1, forcing it to be invalid. So we can do this. So even if it generates 0.10,009s or something crazy like that, it would then generate 7 point a ton of 9s and be rounded down to 7, which is legal. So that's perfectly safe. This should always work, and this is a great way to grab a random value from an array, which we did here. So species will be one of those properties now. So level, this one uses a bit of a complicated concept, which I have added in a comment. It is a select between a range option. So the idea here is we have math.random times max minus min. So max is your maximum level, min is your minimum. So let's go with the 4 and 2 example. So 4 minus 2 is 2. So you generate a random number between 0 and 2, but not including 2. And then we round it, which means it can be rounded up or down. So between 0 and 2. It could be 0, 1, or 2, since we used round, not floor or seal. then we add the minimum value to it. So this first giant chunk before the add is basically we want a differential range. So if you take your minimum, we want to either have, your minimum is 4, so we want 4 or something between or equal to the max, so 5 or 6. The idea here is there are two possible numbers after the minimum. So if we add either 0, 1, or 2, we will get a valid number here. And that's the concept behind this here. If we take max minus min, the difference between those two, that's the maximum number of levels we can add to minimum to have a valid number still that's within maximum. We get a random number between 0 and that, including that, and then we add that to min. So if it's 0, we get the minimum, and if it's that difference in the end, then it's the maximum. If it's something else, it's something between it. So this will generate a number between 2, 3, and 4. Again, if that's complicated, shoot me questions. That's what we do here with level, where min is this type species 1, or that's max, and min is this type species 0. So this refers to this route object. Type in brackets, type is going to be grass or water in my script's case. Species is going to be the specific species property, so if we encounter a lotad, it's going to be referencing this. So we go from route this to grass, which is type here, to lotad, the species we are generating. And then 1 would be the max, 4, and min would be the 2, the minimum level. That's the concept there. Shiny, same kind of general idea. We do a math.random times, I chose to use the shiny charm rate of 4096. And I round it up, so we get between 1 and 4096. And if it's equal to 272, any one single number would have worked here. You could have done 1, you could have done 4096. I chose to do 272. And it's going to be true or false. That's going to be equal to that since you're checking if they are equal. And it's going to be right 1 in 4096% of the time. So then we log a wild. If it's shiny, we log the word shiny in all caps. Level, then it's level. Its species appeared in the grass, water, whatever. So we complete that part of the assignment. We log what we encountered, if it's shiny, its level, and where we encountered it. So if it's shiny, we increment the shiny encounters value now because we just finished calculating that. Then we log that we threw a Pokeball, caught equal this.tryCatch. So we're going to jump down here for a sec. TryCatch is our Pokeball throwing method. As explained in the instructions, it returns true or false. And it does it a certain percentage of time of your choosing. In this case, I just did 50%, nothing fancy. So it's going to return math.round, math.random, not math.round, not math.random. So starting with this simply, math.random again is going to generate a random decimal number between 0, including, and 1, not including. Yes, again, it could generate exactly 0, but that's almost never. So then we round it. So standard rounding rules, we round this decimal up to 1 or down to 0. So you're going to end up with 0 or 1 from math.round, math.random. But what do the two nots do? Well, not turns something into a Boolean, the opposite of what it is. So if you do not 1, you end up with false. So this is my trick. You might have done something different in yours if you did it, and that's fine. This is a little complicated for newer people to get their heads around. But truthy and falsy, 0 is considered falsy, so if you do not 0, you end up with true, and if you do not 1, you end up with false. They're two different things on the true-false spectrum. And if you do not on something, so like if you say that's not true, you're saying that something is not true. If you caught that there, you're basically, it's the equivalent of saying that something is true. That's why you don't have double negatives in English. It's pointless. Over here, its point is to turn this into true or false. So if you roll 1, it's going to say not 1, that's false, then not false, which is true. And if you roll 0, it's going to say not 0, which is false, which turns into true, and then it's going to say not true, which turns into false. I apologize if I've wrapped anyone's head up into I don't know what now, but the idea is this returns true or false 50% of the time. So it's going to assign the return value of that to the variable caught. If caught, so if it got caught, it'll say gotcha, species was caught, species was sent to the PC box. It'll increase the catch count, and if it was shiny, it'll increase the shiny caught value. Otherwise, it'll log the wild species broke out and fled. End of the run encounter method. So that covers the entire route object, all of its methods. So again, we initialize these variables storing information on the encounter. Then we log entered route.name, so entered route 102. So then we take 500 steps. So let I equal 1, I is less than 500, or equal to 500, I plus plus. So we loop 500 times. We set the encounter type to grass. Our check in here to handle the bonus for changing type is if I is greater than or equal to 250 and I is less than 300, we set type to water instead, and then we try an encounter. So, yeah, there's that. I thought I did something. Actually, I did do this slightly differently in my Java version. I wrote a Java version, but that's fine. So, results. At the end of this whole thing, after we log that entire thing, we log our results. Arrived at the end of route.name. Encountered a total of encountered Pokemon. Shiny appeared, encounters were shiny. Caught a total of catch. Number of caught Pokemon were shiny. So it logs all the information at the end, and that fulfills the requirements there. So we're going to go ahead and run that, of course, because why wouldn't we? Let's see, node, what did I call this? Out solution, if I could type. So that's going to do a lot of logging because it's 500 entries, but we'll look at some of these here. So for example, a wild level 2 Wurmple appeared in the grass. Wurmple can appear between levels 2 and 4. So this rolled the minimum, threw a Pokeball, gotcha, Wurmple was caught, Wurmple was sent to the PC box. And here's another one, a wild level 2 Poochyena, 2 to 4 again. And it broke out this time, and there's all sorts of examples around here. So if you look up to here, you see it switches from in the grass to in the water for an extended period of time, and it's not always the same amount. It's only 10% of the time you get an encounter. At the end, we encountered 55 Pokemon, no shiny encounters. We caught 30 of them, and of course we caught 0 of 0 shinies. If I run this a few times, we may get a shiny. Not this one. I'll just run it 3, 2, 1 more time. And we're not getting a shiny today, apparently, but that's fine. They're pretty rare. I know I ran it a couple times to try to see if I could get a shiny, but I didn't end up rolling one. Or, well, I did in my Java version once. It takes quite a while if you're going to try to run a shiny. But, yeah, your odds are pretty against you. Either way, it works. So, that's that. Our next assignment is called the Safari Zone. I will have it posted soon. The idea is you will be encountering Pokemon and being more detailed in the catch system by using classes and a few other things. So we're making steps towards the end of the class here. So hope you look forward to that. We've got something good planned. So that is that then. Alright, thank you very much for watching, guys. If you're interested in the class and this is your first time here, this is the link to the class info, this is the Discord link. We'll see about a stream schedule. I still got to keep it all worked out, but we'll be back soon, potentially tomorrow, we'll see. And we'll be moving into errors and potentially more because that's a fairly small subject. Errors, NodeJS file systems, some other things in JavaScript like maps, sets, dates, and potentially looking into PS more. So, yeah, thank you very much. And why don't we raid? How's that? I know exactly where to send you guys. If I could remember the name of it, that would be very helpful. Yes, that would, if I could type, that would be great. This is probably what I'll be watching afterwards, so feel free to hop in if you want a few channel points before we head off. But yeah, so thank you very much, guys, and we'll see you next time.